Okay. So today we are going to discuss about deployment and operation consideration.
Okay.
Operational consideration. So basically, till now we covered means how we need to plan the things, am I right? And what thing need to be taken care. But
Right.
end of the day, we need to go for deployment
Right.
and what thing need to be taken care and what problem we can face
Okay.
and what kind of deployment strategies are there.
Okay.
We will, in this topic, we will cover all this,
Okay.
right?
Okay.
So basically, if you talk about the first part of this, then we need to think about the environment.
Okay.
In a, you can say, software development life cycle, we have a different phases or life cycle
Yes.
phases, am I right?
Yes.
Like development is there,
Yes.
testing is there,
Yes.
then you can say this staging is
Yes.
you can say pre-production is there,
Yeah.
and then production.
Production.
Right.
Yes.
And in this means we will keep the things separate so that while development means developer can feel free and done their you can say things without any fear. Okay, without any fear of disturbing means you can say real user or actual user.
Right.
Okay, same thing for testing. They have a test data.
Okay.
Means maybe on a development we don't have much data,
Yes.
but for testing they have a means data, proper data, so that they can test means the unit testing. They can perform unit testing, performance testing, and
Right.
other testing.
Right.
And then after testing, we have staging means pre-production, where we will means give a actual things means which is required on production,
Okay.
specifically on production.
Okay.
Like you can say scalability is there, load balancer and things are there.
Okay.
Maybe it cannot be available on our this lower environment like development or this. So it's a pre-production.
Okay.
So that before deploying, you can test and verify everything.
Okay.
Okay, because we have a multiple components.
Right.
So first thing is first environment.
Right.
And then we need to consider about configuration.
Okay.
Am I right? In a configuration management, we need to manage a configuration for a different environment and whatever require, maybe it's a secret, it's a database connection string, API keys, am I right?
Right.
Or timeout options.
Right.
So we need to manage the configuration.
Okay.
Okay. So that if there is a mismanagement, then our operation will mean deployment is fail.
Right.
Then after that means after we managing this configuration, we will move forward.
Right.
And we will discuss about this rollout and rollback.
Right.
Strategies.
Right. Right.
So how we are going to deploy this? We will go in a one go. We will going to roll out in a one go. We will do in a phases manner.
Right. Right.
So we will decide and discuss the strategies there.
Okay.
After means after this rollout and this, we will discuss about operation risk.
Okay.
What are the operation risks? Operation risk can be a means during operation maybe user is means entered a wrong configuration.
Right.
Am I right?
Right.
Or user is you can say means wrong configuration or misconfiguration.
Right.
Right. Means database. This is a production database, and he used production database for this development. Am I right? So these are the operation risks which we need to consider.
Okay. Okay. Okay.
Okay.
Okay.
After you can say considering this operation risk, we need to discuss about you can say flag base,
Hmm.
flag base, you can feature flag,
Ah.
and you can say feature flag and control list.
Okay.
Okay, how we can means
Okay.
without interrupting, how we can means test on a live environment or with a real use cases or real thing
Okay.
on a with the help of flag.
Okay. Okay.
Okay.
Right.
So if user means for tester or for internal testing, they will mean let's say decided a flag. This is a
Okay.
new. You can say if new is true, then only means these user can test. Am I right?
Okay. Okay.
New flag is applicable for this user so that they can test. Okay.
Okay.
And for another user, whatever normal user we have, they are using with a default one.
Okay. Okay. Okay.
Understand? My point?
Right.
So,
Right. Okay.
and apart from that, we next we need to think about this deployment.
Right.
There we will discuss about this blue, blue, green, and canary deployment.
Right. Right.
Blue green means we have a two production deployments environments are ready,
Okay.
and initially we will give some load to the you can say secondary one,
Okay.
and gradually will increase the you can say traffic there.
Okay.
Then when it's finalized, then we will swap this
Okay.
or
Okay.
change this. Okay.
Okay.
Canary is a you can say think of
Okay.
means we will means step by step do the means incremental load and do the testing. When it's stabilized till 100%, then we will consider this for a
Okay.
production.
Okay. Okay.
Okay, and then means there is a term called configuration drift.
Okay.
Okay,
Okay. Okay.
configuration drift means the idea is this: our production
Okay.
and you can say this staging both are should be in a sync. Am I right?
Okay. Okay.
But if someone made changes in a production or
Ah.
staging, vice versa, am I
Ah.
right?
Ah.
So that can be a harmful. Right?
Ah. Okay. Okay. Okay.
So means for that we need to maintain some
Hmm.
documentation, some track,
Hmm. Hmm. Hmm.
or we need to manage. Means no one can do this manually.
Right.
Okay, there
Right.
should be some proper way to do
Hmm.
that.
Hmm. 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 Hmm.
And you can say then we need to talk about this readiness,
Okay.
deployment readiness.
Right.
Means deployment is not about this deployment and environment configuration. No,
Hmm. Hmm.
it's more than that. Am I
Hmm.
right?
Hmm. Hmm. Hmm.
Means observability is there
Hmm.
and monitoring is there or not.
Hmm.
Am I right?
Hmm. Hmm.
We need to make sure that as well.
Okay.
If it's not there, then means or it's there, but we
Hmm.
are not considering, we are not analyzing those
Hmm. Hmm.
during this life cycle of the you can say this,
Right.
then it's fail.
Hmm. Hmm. Hmm.
Right. So for that we need to do that, and in
Okay.
the last we need to consider about deployment safety
Hmm.
and observability.
Hmm. Hmm. Okay.
Deployment safety means we need to consider safety measures
Hmm.
as
Hmm.
well as observability. We already discussed
Okay.
observability in detail.
Right.
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 And now question arises why so many environments are required
Yeah.
and why we are going with the configuration.
Right.
I'm asking, what do you think?
No, for example, see the site wherever we want to deploy should be ready. Should be in the ready in the sense. First of all, the server should be in place. The network should be in place, and the server should have the proper configuration. So only when these things are in place, I can go and deploy it. Otherwise, difficult. So The readiness and configuration is like we're expecting the site to be ready for deployment. Even if one thing is, for example, if there's no network at all, or if the server is not having the proper configuration, I cannot deploy at all. The whole thing will be a failure. So before doing that, yes, the site should be ready.
Yes. So means environment is also different, so that you means anyone can feel free to and do the thing.
Yes.
Okay, whenever it's ready, then we can safely, with the confidence, we can move ahead.
Yeah,
Right?
correct, correct.
And we need to consider, you can say, life cycle of software development life cycle as well. We cannot ignore.
Right.
Okay, so with this knowledge,
Mm.
I will request you please go through that. So
Okay.
if you have any question or concern, we can discuss there. Or if
Okay.
I think I can interrupt you in between and ask some question, or I can means add more information if required.
Okay. Okay. Okay.
Go ahead. Go ahead, please. Go ahead, please.
Yeah, I'm going. Deployment and operational consideration. Why this module is covered in depth. Module 13 focuses on how systems are released, operated, and received in real production environments. Many well-designed systems fail not because of architecture, but due to poor deployment practices, misconfiguration, or unsafe rollouts. Okay, this module builds operational maturity by teaching engineers to deploy changes safely, manage configurations reliably, and reduce the risk during system evolution. Correct. Environment separation concepts. What environment separation involves maintaining distinct environments such as development, testing, staging, and production. Okay. Environment separation. Okay, why? Why? Separation prevents untested changes from impacting live users. Yes. When? From the earliest stages of system development. Use case. Food delivery. New features are validated in staging with production-like data before being released to live users. Okay. Plain English understanding. A system should not go directly from developer machine to real users. Yes. Different environments act like safety layers. Each one helps teams build, test, validate, and release changes with less risk. Engineering view. Typical environments include development for local building and debugging, testing for automated checks and integration validation, staging for production like verification, development for local building and debugging. Okay, fine. Testing for automated checks and integration validation, then staging for production like verification, production for real users and live traffic. Okay.
Yeah. So for testing, we have a different, you can say, testing. So we can test, you can say, backend API, or you can say means automation testing is there. And after testing this, we have a UI testing. Right? Then after UI testing, we have this, you can say, integration testing. They will test the things in an integration manner. So those things need to be considered and automated, so that if something will break, then it will alarming situation and we can capture early.
Right.
So whatever we discussed, observability and this is required on each and every phase of the software development license.
Right. Then each environment should have clear purpose, isolated resources, then controlled access, environment-specific configuration, repeatable setup. Yeah, yes, I have to repeat in multiple places. Okay, fine. Right. Example, a new order status flow is first built in development, validated in testing, checked end-to-end in staging, and only then released to production. Okay, new order status flow is first built in development, yes, validated in testing, checked end-to-end in staging, and then only then released to production. Right. Configuration management. What? Configuration management controls how environment-specific values are stored and applied. Configuration management controls how environment-specific values are stored and applied. Why? Okay, hard-coded configuration lead to deployment errors, yes, and security risks. Whenever systems run in multiple environments or region. Use case. Database endpoints, API keys, and feature flags are configured externally, not embedded in the code, right? Plain English understanding. The same application code may run in many places, but each place needs different settings. For example, staging should connect to staging database, while production should connect to production services. These values must not be manually edited into code every time. Okay, right. Okay, engineering view. Got it. Engineering view. Engineering configuration often includes database URL, service endpoints, API key, then secrets, timeout values, retry policies, feature flags, region-specific values. Okay. Good configuration management means externalized configuration, secret separation from normal config, environment-specific overrides, version control for non-secret config where appropriate. Version control for non-secret config where appropriate. Validation before startup or deployment. Yes, right. Example, order service should read, yeah, payment endpoint from config, timeout value from config, timeout value, feature toggles from config, secret, okay, Deepak, feature toggles from config, I didn't get that.
Okay, so as I told you, there is a, you can say, controlled and feature flag based canary.
Okay.
So it should be means changeable from configuration.
Okay.
Otherwise, what happens if you are not if it's not a configurable, right? Then you need to redeploy it after that.
Okay.
To avoid those things, we will keep the things in a configuration so that we have a better control.
Okay. Rollout and rollback strategies. What? Rollout strategies define how new versions are released. Rollback strategies define how to recover. Yeah, for example, something goes wrong, we should gracefully roll back everything. Okay, fine. While safe rollouts minimize user impact and allow quick recovery from issues. Correct. When for every production and deployment. Correct. Use case. Gradual rollout of new order flow workflow with the ability to instantly roll back on errors. Yes. Plain English understanding. A release should not always go to all users at once. Yeah. Safer releases happen in controlled steps. If something goes wrong, the team should be able to stop or reverse the change quickly. Right. Engineering view. Common rollout strategies include full rollout, phase rollout, canary deployment, blue-green deployment, feature flag based release. Okay, here, Deepak, one small doubt was coming. Like, see, now let's say I want to roll a new feature. Okay, that feature includes a table change. For example, a new column I want to add. A new column I want. So now in my configuration file, in my setup file, what I do is I go and alter the table. I add a column, new status, some column is there. I added it. Then I started deploying the application. While deploying, I found that there are some errors. So now I need to roll back. So when I'm trying to roll back, I should drop that column also no in the table.
Why not? Because whatever is not required, that's a strategy we need to think of. Hey, what are the changes which you are going to deploy so that while rolling out and when you roll back, then what thing you need to remove. If let's say you require 2 more configuration, right? Or you require a change updation of configuration so that your new version will work, right? Or new feature will work. But it disturb your existing. So in a rollback strategy, you need to mention that. During rollback, we need to change here and here, then it will work. If you not mention those steps, then you will face problem.
Yeah, because the rollback, the whole program also will fail because new column is introduced, insert segment will fail, everything will fail. Okay, so that also we should consider.
Definitely.
Okay.
Then think of you are going to organize an event, right? And in an event, you need whatever you plan. While you just when event is finished, you need to take that checklist and which means check this crockery is there, fine, and these tables are there, fine. Right? So we'll same thing with the rollout and rollback.
Okay.
Okay.
Okay. Fine. Rollback strategies may include reverting application version, shifting traffic back to previous version, disabling new functionality with feature flags, yes, restoring safe configuration, compensating for bad data if needed. Okay. Example, a new payment retry flow is released first to 5% of traffic. Observability shows increased timeout errors. So traffic is immediately shifted back to previous version. Okay. Right. Operational risks. Operational risks are failures caused by deployment, configuration, or operational mistakes. Operational risks are failures caused by deployment, configuration, or operational mistakes. Why? Operational errors are a leading cause of outages. When continuously assessed during system operation and change management. Okay. Use case. Misconfigured timeout values causing cascading failures during peak traffic. Right. Plain English understanding. Even if system design is good, operation can still break it. A wrong configuration, unsafe release, expired certificate, or missing rollback plan can create major production incidents. Correct. Right. Engineering view. Common operational risks include incorrect configuration value, secret leakage, incomplete environment setup, manual deployment mistake, dependency version mismatch, schema change without compatibility planning, wrong scaling limits, bad timeout or retry settings, traffic routed incorrectly, failed rollback processes. Okay. Example, a timeout change from 2 seconds to 30 seconds may cause threads to remain blocked longer, leading to queue buildup, latency spikes, and cascading service slowdown. Okay. Yes. Correct. Yes. Deployment, testing, staging, and production. What? These environments separate the life cycle of software.
Hold on.
Yes.
Tell me what till now,
Ah.
which 4 topics we covered?
Which?
4 topics we covered. This is a 5th topic. We covered 4 topics.
Yes.
What are those?
Okay. One is 1 minute. Okay. First 4. We have seen the development, testing, staging, and production. Okay. We want the first 4. I'm just going to recollect 1 minute. So before deployment, testing, staging, and production, we are covering development here. Okay. Development, testing, staging, and production. One is site preparation, that is pre-production. Environment, yeah. One is environment. Okay. And okay, now, yes, so I am ready now. So that means all the development work is done. Then, okay, environment, okay, yeah, that is the first one. I'm checking whether environment is okay or not. Yes, okay. Just give me, just let me think, Deepak, just a minute. Okay. Okay, what is environment? The other, okay. Development is one. Okay, so now you are deploying. One is you're checking for the environment, and then okay, can we include configuration check? For configuration check,
yes, second is configuration management.
Okay, configuration we are checking, and then we have to take care of the this one, that is rolling back the changes if any problem occurs.
Yes, rollout and rollback strategy.
Rollback. Okay, and then fourth one, that is okay. Now during employment, I found some problems, so I have to gracefully roll out all the changes. Yes, and allow them to fine. Okay, and before releasing to all the users, you have to release it for selected users and test, and then only release to all users. I mean,
No, no, no.
controlled release.
No, we will discuss that later.
Ah,
But right now, the only point you left
ah,
is operation risk, which
ah,
we discussed.
oh,
Fourth one is operation risk.
okay, 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 okay.
Okay.
Right, right. Okay.
Why I ask this in between so that your mind is alert.
Right,
A surprise test,
right,
MRA,
right.
and you will means in this way we will able to improve your tendency to remember the things and
Ah,
means study the things with care,
okay, okay, okay.
with extra care. Okay.
Right, right,
Don't mind. Okay.
right.
Just it's for
No,
your benefit.
yeah, yeah, correct.
It's
I know.
beneficial for you.
No, you are doing everything from my benefit only. Okay. Right. Deployment, okay, development, testing, staging, and production. What? These environments separate the life cycle of software change from development to live release. Then why? They reduce the chance that incomplete or unvalidated changes affect the real users. When? As soon as system is more than a simple local prototype, then plain English understanding. Okay, each environment exists for different reasons. Development is for building, testing is for checking correctness, staging is for final validation, production is for real usage. Fine. Engineering view, development, fast feedback, experimental changes, local debugging, testing, automated tests, integration checks, validation of service behavior, staging, production-like environment, pre-release verification, realistic end-to-end testing, right? Production, live users, strong controls, monitoring and rollback readiness, right? Example, a delivery assignment feature may pass local test, but staging reveals that the read like event volume creates queue delay. This is fixed before production release. Okay, fine. Then feature flags and controlled release. Okay, feature flags and controlled release. What? Feature flags allow system behavior to be enabled or disabled without redeploying code. Oh, okay, right. Why? They reduce release risk by separating deployment from feature exposure. Okay, fine. Then when features need phased release, fast disablement, or controlled testing. Fine. Plain English. A feature flag is like a switch. Okay, code can already be deployed, but feature remains off until the team is ready. Okay, if problem appears, the feature can be turned off quickly. Oh man, uh, it requires so much of planning, Deepak. Oh my God! In fact, even while development time, also we should think of having a switch for the feature.
It's not a development. It's you can say means we are developing a new feature without disturbing existing feature.
Correct.
But we are then deciding
Ah,
how you can use that. We will give a flag there.
that's what I'm telling.
And yes,
Yes. So, see, I should have a facility. I should think that, okay, I should give facility for them to use a feature when they want to. That means I
yes,
should have a flag. So that pre-thought, no, that's what it requires a lot of thinking and planning. Blindly, okay, somebody wants a feature, develop it and keep it ready. No, now this is a new point for me where we develop and with all the features, whatever they want, but still it can be controlled whether
yes,
to
yes.
give or not. Okay. 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 This I didn't think of it at all. Okay, fine. Right. Okay. Engineering view. Okay. Feature flags are useful for gradual exposure. Yeah. AB experiments. I don't know. Okay. Operational key switches. Yeah. Internal only release. Oh, okay. Regional rollout control. Okay. Nice. Okay. Then example, a new recommendation engine is deployed but enabled only for internal testers first. Later, it is expanded to 10% of users, then to all users. Wow, beautiful. Okay. Blue, green, and canary deployment. Blue, green deployment uses two production environments, while canary deployment releases to small subset of traffic first. Okay, right. And then next, why? These strategies reduce risk and improve recovery. Yes, correct. And then when, for high impact or high risk production. Yes, okay. Plain English understanding. Blue green means keeping two production 90% ready and traffic, switching traffic between them. Canary means sending only a small amount of users of user traffic to new version first. Okay, fine. Engineering view. Blue green deployment. Blue equals the current deployment production. Green is new version. Okay. Switch traffic after validation. Easy rollout by returning traffic to old version. Okay. Canary. Deployment, the deployment. New version, this is small traffic share first. Metrics and errors are watched closely. Rollout expands only if healthy. Example, a new order pricing services version is released to 2% of the traffic. If error rate stays normal, rollout move to 10%, then 50, and then 100%. Okay. Configuration drift. Okay. Configuration drift means environments become unintentionally different over time. How? Let me see. Why? Drift causes works in staging but fails in production problem. Okay. Whenever environments are changed manually or inconsistently. Okay. If environments are supposed to be similar but slowly diverge, teams stop trusting pre-production testing. A release that looks safe in staging may behave differently in production. Okay. Engineering view. Configuration drift often comes from manual edit, undocumented fixes, inconsistent secrets, different service versions, different scaling rules, different timeout values, missing infra automation. Okay, example. Staging uses one retry policy while production uses another. A feature works in staging but causes overload in production because retry behavior is different. Okay.
Okay, so right now, time for revision. Means how many points we covered till now?
Eight points.
And what are the purpose of those?
Develop.
Topics, titles of those.
Yeah, one is the development, testing and staging. Second is the other one is blue green canary test, and then well, this one, the other one is blue green canary. Then configuration. Uh,
Okay. Configuration drift. One more left.
Undocumented.
Feature flag and control.
Feature flag and control. Yes. Okay. Right.
Okay.
Right.
And just give me just a revise whatever we discussed, all the 8 points quickly, because
Yeah.
those are the important ones.
Okay, fine. Okay, fine.
Whatever you know, just quickly revise the things.
Okay. I mean, right from first point.
As you wish, you can means take any point, but
Okay.
I won't mean we will develop this habit.
Ah.
Means so that our mind is active for this kind of challenges.
Okay. Okay, fine. So, brief points. Okay, I'll try to tell point by point, like in points wise. Okay, one is before releasing any new version. For example, if I want to, for example, I have changed the payment retry options. I did some change in the payment retry option. Now, before releasing it to all the users, first test it to 2% of the users, and if the error rate remains the same, then deploy it for all the users. That is one of the points I got. Then the other one is then environment plays a very important role. Keep the environment ready, have all the configurations in place, and then you verify. And then, yeah, more other important thing which I learned today is that feature flag. Like you have developed say 2 to 3 features. Yes, you're deploying the application with all the features, but there is a flag which can be enabled and disabled, which indicates that yes, this feature can be released, this other feature can be blocked. So that flag we are giving. So feature wise control we have, which feature to release, which feature not to release, but application is deployed with the features, but with a simple flag stating go with this feature, control the feature, because in case of any issues we can always stop that feature, go back to the drawing table, rectify, and then again go and deploy it. Okay, so that is one of them. And then okay, that is point. Other point which I came across, that blue green canary. So blue green indicates new version. Canary, canary yet to be tested. That some confusion is there in that. Okay, that I need to clarify. So staging environment of flag I told. Then we covered environment, and then okay, feature flag we covered. Feature flag we covered, and then the other one is 1 minute. Feature flag we covered, and then the other one is the other one. That one just thinking. Staging, production environment.
No worries, no worries.
Okay. Okay. Then operational readiness. Operational readiness is a condition where a system is prepared to be safe in the production. Operational readiness. Okay. Operational readiness is a condition where a system is prepared to be safely run in production. Why deployment is only one part of the production safety. One part of production safety. Deployment is only one part of production safety. Teams also need observability. Oh, another point I forgot. Okay, observability, recovery plans, and control mechanisms. Okay, when before every important release and throughout the service ownership. Okay, fine. Plain English. A service is not ready for production just because it works in testing. It must also be operable. Teams should know how to deploy it, monitor it, troubleshoot it, and recover it. Okay. Right. Engineering view. Operational readiness usually includes health checks, dashboards, alerts, documented rollback steps, run books, safe defaults, access control, capacity expectations, dependency awareness, backup and recovery planning. Okay. Example, before releasing a new payment connector, the team confirms metrics exist, alerts are configured, rollback path is tested, secrets are present, dependency limits are understood. Okay. Deployment safety and observability. Okay. Deployment safety means watching production behavior carefully during and after release. Many rollout issues appear only under live traffic and production scale patterns. Okay, when during every production deployment window and post-release monitoring. Fine. Plain English understanding. Releasing code is not the end of the process. Okay. The system must be observed during rollout to make sure latency errors, and business flows remain healthy. Engineering view. Important rollout signals include error rate, latency, throughput, resource usage, queue depth, dependency health, business success rates, rollback trigger conditions. Okay, example, a new order processing version is rolled out. Okay, error metrics remain stable, but order confirmation success drops. Okay, this indicates a business workflow issue that must be caught quickly. Okay. Okay, deployment. Okay, development, testing, staging, production. Okay. Safe roll and very important. New version ready, deploy to small traffic slice, monitor as latency. Healthy, increased traffic. Issues found, roll back quickly. Full back. Okay, fine. Roll back. Visual externalized configuration, externalized application code, read configuration at runtime. Okay, database endpoint, API keys, timeout values, and then feature flags. Okay. Common mistake: deploying directly to production without, my God, untested changes reach live users too early. Hard coding environment values. Oh my God, no way. Secrets, endpoints, and flags become difficult and dangerous to manage. Right. No rollback plan. Teams know how to deploy, but not how to recover. Okay. Ignoring staging differences. Production behaves differently because pre-production is not realistic enough. Okay. Manual configuration. Okay. On-track ready checker. Okay. When hardcore debugging. 100% of immediately. Yeah. Blast radius becomes too large when the version is faulty. Poor monitoring to doing reload. Okay. Teams miss early warning signs and react too late. Okay. Treating of operations separate from design. Operational issues are architectural concerns too. Okay. Okay. Have to go through. Okay. Okay. Deployment and operational maturity comes from separating environments, externalizing configuration, releasing changes gradually, and preparing fast recovery paths for when production behavior goes wrong.
Any question or concern?
No, again, I have to go, but very beautifully put. So, and is so important, so important. I hope, companies, they really go through all these and then take care of things.
Okay. But you need to learn and implement so that they can follow you. Hey, yes. You understand my point?
Yeah, correct. Interesting.